Good afternoon, students. Today I am going to be working through your test 2.2 review so that you can get help on some of these questions before your test tomorrow. I'm going to work through each problem showing all of my work, and if you're still stuck, I'll be tutoring tomorrow at 7 a.m. Number 1. Squares are constructed using the three sides of a right triangle as shown below. If the two legs of the right triangle are 5 centimeters and 12 centimeters, what is the area of the largest square A? So I'm looking for the area of this largest square, which is on my hypotenuse. So I'm going to use A squared plus B squared equals C squared. I know the area of this small square here is 25, and the area of this larger square on the leg is 144. So I'm going to plug those into my formula. Now, because those are the areas, I don't need to square them again. So I'm going to add 25 to 144, and I get 169 equals C squared. Because I am looking for the area, I do not have to square root, and my final answer is 169 centimeters squared. Number 2. Which model demonstrates the relationship A squared plus B squared equals C squared? So for this problem, we're looking at the number of squares on the legs and seeing if they add up to the number of squares on the hypotenuse. So I've got 12 here and 6 here, and then on the hypotenuse, there's 10. So 12 plus 6 does not equal 10, so it can't be A. B, we have 3, 4, and 5. 3 plus 4 does not equal 5, so it can't be B. C, we have 6, 8, and 10. 6 and 8 do not equal 10, so it's not C. And letter D, we have 9, 16, and 25. So 16 and 9, if I add those together, I do get 25. So letter D shows A squared plus B squared does in fact equal C squared. Number 3. A 24-foot tall pole stands next to the highway. A 25-foot long support wire stretches from the top of the pole to the ground. How far away from the base of the pole does the wire meet the ground? So I'm looking for this part of my triangle here. That's one of the legs because it's part of the 90-degree angle. So since it's a leg, I'm going to have to subtract C squared minus A squared equals B squared. So my hypotenuse, remember, is always the longest side. So I'm going to use 25 for C, and I'm going to use 24 for A. 25 squared is 625. 24 squared is 24 squared is 576. You're going to subtract those, and you would get 49 equals B squared. And then our last step, since we're looking for a side length, is we are going to square root. So we would get 7 equals B. So the wire is 7 feet away from the base of the pole. Number 4, the right triangle shown below, if formed by joining 3 squares of their vertices. What is the value of x, the side length of the bottom square? So we're looking for one of the legs again, so we're going to subtract. Remember, C squared is always our hypotenuse. So I'm going to substitute 400 in for C squared. Now this is the area of the square, so I do not have to square it again. And then 12 will be A. And because 12 is the side length of that square, I'm going to have to re-square it. So 400 minus 144 equals B squared. It's 256. And then because it's asking us for the side length, we're going to go ahead and square root. You should get 16. Number 5. Determine the distance between the points given below, round to the nearest tenth if necessary. So the first thing you're going to do is plot your points. Now remember, your points are x, then y. So 1, 5, I go right 1, up 5. And 3, 1, right 3, up 1. So we're looking for the distance between those 2 points. Remember, you cannot count diagonal distance. Instead, we're going to draw a right triangle, find the side lengths, and then use that to use the Pythagorean theorem to find the distance. So 4 squared plus 2 squared equals c squared. 16 plus 4 equals c squared. 20, if you add those together. And then your last step is to square root. Now the square root of 20, if you round to the nearest tenth, is about 4.5. Now we're going to do the same thing for the next problem. Start by plotting your points. 4, 5, I'm going to go right 4, up 5, 2, 2, right 2, then up 2. Draw your triangle. 1, 2, 3 squares, and then over 2. So 3 squared plus 2 squared equals c squared. 9 plus 4. So you get 13. And then you're going to do the square root of 13. Round to the nearest tenth is about 3.6. Remember, whenever you see Pythagorean theorem on a coordinate plane, you're always looking for the hypotenuse. Number 6. A 20-foot ladder is leaning against a wall, is used to reach a window that is 17 feet above the ground. So in problems like this, always draw a picture. We're looking for how far from the wall is the bottom of the ladder. So my ladder is 20 feet, and the window is 17 feet high. So I'm looking for this side down here. That's one of my legs, so I'm going to have to subtract. So c squared minus a squared equals b squared. 20 squared minus 17 squared equals b squared. 20 squared is 400. Then you're going to do 17 squared, which is 289. When you subtract those, you get 111. Because we're looking for a distance, our last step is going to be to square root. So take the square root of 111. Round to the nearest tenth, and you'll get 10.5. Number 7. You're walking around a square park with sides of 125 feet. At the same time, a friend is trying to catch up to you and cuts across the park diagonally from where you started to where you will end up. So if you're starting here, you go down and over. Each side of the square is 125 feet. So if you start at the top, you go down, that's 125, and then you add 125, you will have walked a total of 250 feet. Your friend is cutting across the park diagonally. So to find that distance, that would be the hypotenuse of our triangle. So we're going to do 125 squared plus 125 squared equals c squared. So 125 squared is 15,625. We're going to add 15,625. Add those together. You're going to get 31,250. And then square root. The square root of 31,250 is 176.8 if you round to the nearest 10th. And then part C says, how much less distance will your friend travel? So we're going to take your distance, 250, and subtract 176.8. If you do that, you should get 73.2. Number 8, find the height of an equilateral triangle using the Pythagorean theorem if each side measures 6 centimeters. Note the height bisects the bottom side of the triangle. So bisects just means it's going to cut in half. So we're looking for the height of the triangle right here. To find that, we're only going to use the left half of the triangle. So I know the hypotenuse is 6, and since the height cuts the base in half, I know that side length is going to be 3. So to find the height of the triangle, it's going to be 6 squared minus 3 squared equals b squared. So 36 minus 9 gives you 27. And then last, you're going to square root. The square root of 27 to the nearest 10th is 5.2. So the height of the triangle is about 5.2 centimeters. What is the perimeter of the triangle? So to find that, we're just going to add up each side. So 6 plus 6 plus 6, or 6 times 3, 18 centimeters. And then lastly, we have the area of the triangle. So the formula for the area of the triangle, area equals base times height divided by 2. So the base of my triangle is this full 6 centimeters. So it's going to be 6 times the height. We already found the height is 5.2. And then we're going to divide by 2. So 6 times 5.2 is 31.2. And then divide that by 2, we get 15.6. So there's all of number 8. Number 9, you're at a hardware store getting tires for your square living room, but you can't remember how much tile you need to get. You find a drawing of your kitchen and living room in your pocket that has the dimensions of your kitchen, but not your living room. Find the area of your living room so you know how many tiles to get with the given information. So part A says, what is the length of the hypotenuse of the triangle? So hypotenuse means we're going to have to add a squared plus b squared to get c squared. So A would be 6.5, B is 8. We're going to square those and add them together. 6.5 squared is 42.25. 8 squared is 64. Add those together. You get 106.25. And then our last step will be to square root. So the square root of 106.25 is 10.3. So the answer to part A is going to be 10.3 feet. Okay. So then, if that's one side of my living room, and I'm looking for the area, I know since it's a square, all of my sides are 10.3. So to find the area, I'm going to do 10.3 times 10.3. And you're going to get 106.2. Okay, number 10. If the three squares come together to form a right triangle as indicated in the drawing, what is the area of x? So we're looking for the area of this square right here. So if my side length is 25, my area is going to be 625. 25 squared is 625. If my side length is 7, the area is 49. And because we're looking for the area on one of the legs, we're going to subtract 625 and 49. So 625 minus 49 is 576. And that's b squared. And we can stop right there because, again, it's asking us for the area of the square, not the side length. Okay, number 11. A string of decorative lights is strung from the top of a fence post all the way down to up to the top of a flagpole that is 16 feet tall. So it starts at the fence post right here and goes all the way up to the top of the flagpole. The fence post is 9 feet away from the flagpole. What is the total length of the string of lights? So we're looking for the total length of this red line. I know this section is 4 feet because it's a square. And so I need to find this last bit right here. To do that, I'm going to draw a right triangle. If I look here, it says it's 9 feet. So I know the base of my triangle is 9. This section of my flagpole is 4 feet if I look over at my picture onto the side. So I know the height of the rest of my flagpole would be 16 minus 4. So I'm going to use 12 as the height of my triangle. So we're looking for a hypotenuse. A squared plus b squared equals c squared. A is going to be 9. B is going to be 12. So 81 plus 144. Add those together, you get 225. And then since we're looking for a side length, square root. So that part of the decorative lights is 15 feet. The question, though, is asking us, what is the total length of the string of lights? So for our final step, we have to take 15 and add 4. And you get 19 feet. Number 12. Rectangle ABCD is shown on the coordinate grid below. What is the distance from point A to C? So A is here, C is here. We're looking for that distance. So draw your right triangle. 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4. So we're going to use 7 and 4 in the Pythagorean theorem. 7 squared is 49. 4 squared is 16. Add those together. Get 65. Square root. The square root of 65 rounded to the nearest 10 is 8.1. Number 13. A right triangle and 2 of its side lengths are shown in the diagram. What is the length of side x? So this is the side we're looking for. That's one of my legs. So I'm going to have to subtract. So my hypotenuse, remember, is the longest side. So it's going to be 39 squared minus 12 squared equals b squared. So 39 squared is 1,521. And you're going to subtract 144 from that. 1,377. And then your last step is going to be to square root that 1,337. When you square root that, you get 37.1 for your side length of x. Number 14. Gus and Mark collect baseball cards and they keep them in plastic sleeves. Gus has 5 plastic sleeves that are full of cards. Mark has 2 sleeves full of cards and 6 additional cards. If Gus and Mark have the same number of cards, how many cards will a sleeve hold? So we have 5x on this side because we're looking for the number of cards in the sleeve. And here, on the other side, 2x plus the 6 additional cards. So 5x equals 2x plus 6. So we need to solve for x. If I've got a positive 2x on the right side, I'm going to add a negative 2x to both sides. These are going to cancel, and then I have 5x minus 2x gives me 3x. And over here, I'm just left with the 6, so equals 6. My next step is to divide. So you're left with x equals 6 divided by 3, 2. Number 15. The model represents an equation. What value of x makes the equation true? So you have negative 3x plus 5, 6, 7, 8, 9, 10 equals 5x minus 1, 2, 3, 4, 5, 6, 7, 8. My first step is I'm going to get my x's together on the same side. Because I have a negative 3, I'm going to add a positive 3x. So I get 10 equals 8x minus 8. Because all of my x's are on the right, I'm going to get my single constants over to the left. So I'm going to add 8 to both sides. Negative 8 and positive 8 cancel. 10 plus 8 gives me 18 equals 8x. And then I'm going to divide both sides by 8. 18 over 8 is 2.25. Number 16. If each set of squares below were joined at their vertices to form a triangle, which set of squares could be used to form the sides of a right triangle? So here we're just seeing if the Pythagorean theorem is true. Do the 2 smaller squares, the areas, add up to the area of the largest square? So here, if my side length is 3, the area of that square is 9. The area of this square would be 49, because 7 times 7. And then the area of the largest would be 144. 9 plus 49 does not equal 144. So this would not be a right triangle if the vertices were joined. Letter G, 6, 36, 81, and 144. 81 plus 36 does not equal 144. So it is not letter G. Letter H, we have 8, which the area would be 64, a side length of 10, so the area is 100, and a side length of 18 And if the side length is 18, the area is going to be 324. So if I add 164, that does not equal 324. So I know it's not H. And then on J, the side length of 8 is 64. 15 is 225. And then 17 squared, the area is going to be 289. If I add 64 plus 225, that does equal 289. So that is a true statement, so the answer would be J. So that is all of your test review. Again, if you have questions, I will be here at 7 in the morning. You can stop by before first period to get any help you need. See you tomorrow.